Welcome to our presentation on calculating HCF and LCM with Java. In this session, we'll explore how to create a Java program that calculates the highest common factor and the least common multiple of two numbers. This is a part of the Class 10 ICSE Computer Applications curriculum. Get ready to dive into some fun with logic and programming. In this problem, we are required to create a Java class named HCF_LCM. This class will allow us to input two integers and compute both their highest common factor and their least common multiple. The objective is to practice basic input, arithmetic operations, and the use of loops and methods. Our class uses four main data members: integers a and b to store the numbers input by the user. We also have integers HCF and LCM to store the calculated highest common factor and least common multiple respectively. This class defines four methods: the constructor, which initializes the data members to 0; the input method, which takes values from the user; then HCF_cal, which calculates the HCF using a loop; and finally, LCM_cal, which computes the LCM using the formula based on HCF. Here's the step-by-step algorithm. Start by initializing the variables. Input two integers from the user. Determine the smaller of the two values. Loop backwards to find the highest number that divides both, which is the HCF. Then calculate the LCM using the formula, product of a and b divided by HCF. Finally, display both values to the user and end the program. The constructor method sets the initial values of a, b, HCF, and LCM to 0. The input method uses the scanner class to accept two integers from the user, which will be used for further calculations. To calculate the highest common factor, or HCF, we follow a simple but effective logic. First, we determine which of the two numbers, a or b, is smaller. This is important because the HCF cannot be greater than the smaller number. Next, we use a loop that starts from this smaller number and goes down to 1. In each iteration of the loop A, we check if the current number divides both A and B without leaving a remainder. In other words, we use the modulo operator % to test whether a %i equals 0 and b %i equals 0. The moment we find such a number, we know it is the highest number that divides both values evenly, that is, the HCF. We then store this value in the HCF variable and exit the loop immediately using a break statement, as there's no need to check further. The LCM is calculated using a standard formula, which is LCM equals the product of the two numbers divided by their HCF. This makes use of the mathematical relationship between HCF and LCM. In the main method, we create an object of the HCF_LCM class. We then call the input method to take values from the user, followed by calls to the HCF_cal and LCM_cal methods to perform the calculations and display the results. In this slide you will get the full program link which you can execute the entire program. Also, program link is available in the description box. In this slide, we'll look at the variable description table, or VDT, which lists all the variables used in our program and explains their purpose clearly. First, we have the variable a. This is an integer that stores the first number entered by the user. Next is b, another integer that stores the second number. Then we have HCF. This variable stores the result of the highest common factor after the calculation is done. Finally, LCM is used to store the least common multiple once it's computed. Using OVDT helps us understand the role of each variable in the program and ensures that the logic is organized and easy to follow. Here's an example output. If we input 12 and 18, the program calculates the HCF as 6 and the LCM as 36. This confirms that our logic and calculations are working as expected. Let's recap what we learned. We practiced using constructors, input methods, and loops. We learned how to calculate the HCF by checking common divisors, and how to compute LCM using the product over HCF method. This program helps build a strong foundation in basic logic building using Java. Thanks for watching. Documentation containing question, algorithm, Java program, variable description table, VDT, sample output is also available in description box of this video. Don't forget to subscribe if you are using this for your school or college projects. Happy learning!